In a surprising turn of events, NASA's James Webb Space Telescope has made a discovery that has left astronomers around the world in awe. Just weeks ago, Webb amazed scientists by detecting the earliest known galaxy in the universe. But now, it has uncovered something even more astonishing: a supermassive black hole that appears to be racing away from its home galaxy at an incredible speed of 4 million miles per hour. This phenomenon is not only rare, it challenges some of the most fundamental assumptions scientists have long held about black holes and the structure of the universe. The implications are enormous, and the astronomical community is buzzing with speculation about what this could mean for our understanding of cosmic forces. The James Webb Space Telescope was launched to peer into the earliest epochs of the universe, to capture light from the first stars and galaxies formed after the Big Bang. Already, it has fulfilled its mission with groundbreaking observations. From the deaths of ancient stars to galaxies just a few 100 million years old, Webb has transformed the way we look at the cosmos. Now, this latest revelation is forcing scientists to reconsider long-standing theories about black holes themselves. Traditionally, black holes are thought of as powerful entities that pull everything inward, even light itself. But this newly observed black hole is doing something altogether different. Instead of absorbing light, it appears to be leaving a trail of creation in its wake. Observations suggest that young stars are forming along the trail left by the black hole, stretching across an incredible 200,000 light-years. This behavior is completely unexpected. A black hole speeding through space and triggering star formation goes against everything we thought we knew. Scientists believe that as this black hole plows through interstellar gas, it compresses and cools the gas, creating the perfect conditions for new stars to ignite. This stunning find was initially reported by a team led by Professor Peter Van Dokkum from Yale University and was published in the astrophysical journal Letters. NASA's Hubble Space Telescope also confirmed the anomaly, providing a rare glimpse into a dynamic and creative side of black holes, one never seen before. But that's not the only surprise the James Webb Telescope had in store. NASA also made a major announcement regarding a galactic merger known as ARP 220, captured in striking detail by Webb's infrared instruments. ARP 220 is located about 250 million light-years away in the constellation Serpens and is categorized as an ultraluminous infrared galaxy, with a brightness equivalent to 1 trillion suns. That's nearly 100 times more luminous than our own Milky Way. Roughly 700 million years ago, two spiral galaxies collided in a cataclysmic event that triggered an explosion of star formation. The result? A dense, compact region only 5,000 light-years across that now contains over 200 massive star clusters. Astonishingly, this small area holds as much gas as the entire Milky Way, fueling relentless star birth. Earlier observations with radio telescopes revealed nearly 100 supernova remnants within a space just 500 light-years wide. Webb's infrared vision, however, penetrated deeper. It showed that the parent galaxies are still about 1,200 light-years apart, and each core contains a rotating star-forming ring that emits a dazzling array of infrared light. The most recent images reveal faint tidal tails, wispy trails of stars and gas extending outward from the merger. These features are evidence of the gravitational tug-of-war between the galaxies. The red, ochre, and orange streams in the image also indicate the presence of organic materials, giving scientists clues about the complex chemistry involved in such mergers. But even this cosmic collision pales in comparison to what the James Webb Telescope has just uncovered at the very edge of the observable universe. In one of its most ambitious missions yet, Webb detected primordial galaxies that formed less than 300 million years after the Big Bang. At first, many researchers were skeptical. Could these ancient light sources actually be distant galaxies, or were they just local imposters, objects masquerading as ancient due to redshift anomalies? To resolve the mystery, data was shared with scientists around the globe. The result was unanimous: these galaxies are real. Thanks to Webb's revolutionary ability to detect infrared light in extreme redshifts, astronomers are now able to observe the earliest structures ever seen. The light from these galaxies has traveled for more than 13.5 billion years, giving us a rare glimpse into the dawn of time. These galaxies are helping scientists unravel the mystery of how the first stars and galaxies formed in the early universe. Even more astonishingly, Webb's data revealed that 4 out of 6 of these early galaxies exhibit extreme redshifts, suggesting they formed when the universe was just 300 to 500 million years old, a fraction of its current age of 13.8 billion years. What's more, some of these galaxies are 10 times larger than the Milky Way, despite forming so soon after the Big Bang. This finding has sent shockwaves through the scientific community. According to renowned physicist Michio Kaku, this discovery may require us to rewrite our understanding of the universe's birth. If galaxies that massive existed so early, then the timeline for cosmic evolution may be far shorter than previously believed. Kaku pointed out that it takes billions of years to form a galaxy like the Milky Way. So how could something that massive exist just a few hundred million years after the universe began? The answer could challenge not just current cosmological models, but also the Big Bang theory itself. The current model of cosmic inflation, which suggests the universe expanded rapidly after the Big Bang, might not fully account for these findings. Some scientists have raised concerns about theoretical inconsistencies, such as violations of the second law of thermodynamics and the lack of a clear trigger for the Big Bang event. Even more data from Webb's NIR SPEC and NIR CAM instruments have fueled the debate. The spectral data clearly indicates a lack of heavy elements like carbon in some galaxies, suggesting a rapid formation period with little time for stellar evolution to generate such elements. Adding to the intrigue, NASA recently tweeted about a galaxy cluster that existed just 650 million years after the Big Bang. Astronomers believe this protocluster will eventually evolve into a massive structure like the Coma cluster we see today. By measuring the velocities of the 7 galaxies within the cluster, scientists confirmed that they are gravitationally bound, forming the earliest known steps in galactic evolution. NASA scientists compared the process to small streams of water merging into a powerful river. These developments are raising one inescapable question. What if the Big Bang wasn't the beginning as we understand it? What if there's more to the story, something hidden in the physics we haven't yet uncovered? Webb's discoveries are not just changing science, they're changing our perspective on existence. If galaxies, black holes, and clusters can behave in ways we never imagined, perhaps our entire framework for cosmic history needs to evolve. But as always in science, more data is needed. More time, more analysis, more missions. What comes next could either confirm the Big Bang with greater precision or open the door to an entirely new model of the universe. What do you think about these discoveries? Could they represent the beginning of a new era in cosmology? Are we witnessing the collapse of old theories, or just the birth of deeper understanding? Let us know in the comments below. If this content inspired your curiosity, make sure to like, subscribe, and turn on notifications to follow us here on Waves Discovery, where we dive deep into the universe's most astonishing mysteries. Thank you for joining us on this stellar journey. Until next time, keep questioning, keep exploring, and keep reaching for the stars.